We need to move beyond thinking about sarcopenia, osteoporosis, and cognitive decline as separate conditions of aging. These systems communicate extensively through hormones, signaling molecules, and mechanical forces. Understanding these connections allows for more comprehensive intervention strategies that benefit multiple systems simultaneously. Bones are not just structural support. They're endocrine organs secreting osteocalcin, which influences metabolism, testosterone production, and brain function. Muscle tissue secretes myokines during contraction, including irisin, which crosses the blood-brain barrier and supports neurogenesis and cognitive function. The brain, through the nervous system, regulates both bone remodeling and muscle metabolism. These are interconnected systems, not isolated tissues. Resistance training is the intervention that addresses all three simultaneously, and this is powerful. When you perform resistance training, you create mechanical loading on bones, which signals osteoblasts to build bone. The same exercise creates mechanical stress in muscles, triggering protein synthesis and muscle growth. And exercise increases brain-derived neurotrophic factor, supporting neuroplasticity and cognitive function. You're not just exercising. You're sending beneficial signals throughout this interconnected system. Impact loading is particularly important for bone health through a mechanism that's not widely appreciated. When you create impact forces through activities like jumping, running, or even just walking with purpose, you create fluid flow through the lacunar canalicular network in bone. This mechanical stimulation is the signal for bone formation. Non-impact exercise like swimming or cycling, while beneficial for other reasons, doesn't provide this specific bone-building stimulus. Nutritional support for this axis requires thinking comprehensively. Protein is necessary for both muscle synthesis and bone matrix. Older adults need more protein than currently recommended, probably 1.2 to 1.6 grams per kilogram body weight daily. Calcium and vitamin D are obvious for bone, but vitamin D also supports muscle function and has neuroprotective effects. Vitamin K2 directs calcium into bones rather than soft tissues and also shows cognitive benefits. Magnesium is involved in over 300 enzymatic reactions affecting all three systems. The irisin story is particularly fascinating. When you exercise, muscle fibers secrete irisin, which was initially recognized for its effects on metabolism and brown fat activation. But researchers discovered irisin crosses the blood-brain barrier and enhances BDNF production in the hippocampus, supporting learning and memory. This is a direct muscle-to-brain communication pathway activated by exercise. Osteocalcin from bone affects brain function, potentially supporting neurotransmitter synthesis and cognitive function. It also influences testosterone production in men, which then affects both muscle and bone. This demonstrates how interconnected these systems are. Bone health influences hormones that affect muscle and brain. Balance training deserves specific emphasis because it addresses the bone-muscle-brain axis through a different mechanism: proprioception and neural control. Balance exercises challenge your nervous system to coordinate muscle activation patterns and process sensory information. This maintains neural pathways and reduces fall risk, which is critical because falls are a primary cause of fractures and subsequent functional decline in older adults. The fear of falling creates a vicious cycle. Older adults who fear falling reduce activity, which accelerates muscle and bone loss and cognitive decline. Breaking this cycle through progressive balance training that builds confidence is therapeutically valuable. Here's something that's often missed. The timing of protein intake around resistance training matters for muscle, but the benefits extend to bone as well. Post-exercise nutrition supports both muscle protein synthesis and bone remodeling triggered by that exercise session. Social engagement and cognitive stimulation through activities like dancing are underappreciated because dancing combines physical exercise, balance challenges, social interaction, and cognitive demand of learning steps. It's a multi-system intervention disguised as recreation. The practical protocol integrates multiple interventions: progressive resistance training 2 to 3 times weekly, impact loading through walking or jumping exercises if joints tolerate it, balance training for proprioception and fall prevention, adequate protein intake distributed across meals, comprehensive micronutrient support including calcium, vitamin D, K2, and magnesium, and activities that combine physical and cognitive challenge. This approach recognizes that supporting one system benefits the others through their interconnected signaling. You're not just building muscle or bone or brain function in isolation. You're supporting an integrated system